Hello everyone, I'm Miss H, and today we're going to be looking at how we draw Bohr models. So first of all, what is a Bohr model? A Bohr model is a representation of an atom. It allows us to see what's happening in terms of how many protons, neutrons, electrons, energy levels, valence electrons, that sort of thing that the atom has. Now it is an oversimplified version. You wouldn't want to use this if you were trying to do high level modeling, but for the purposes of an introductory physical science class, it works just fine. When we create a Bohr model, we start out by drawing circles. Now, some people use a circle to represent the nucleus, and some people don't. For my class, I like to use the circle to represent the nucleus just because it makes it easier to kind of see where to put things, but other people prefer to use circles to represent the nucleus, where you have one circle to represent protons and a different circle to represent neutrons. But for my purposes, I like to do a circle in the middle with a P for the number of protons, which is always going to be the same as the atomic number, and an N for the number of neutrons, which is going to be the mass minus the number of protons. When we are doing our models, we're only going to be looking at the first 18 elements, so we don't need to go beyond 3 energy levels. Each energy level has a maximum capacity or a maximum number of electrons that it can hold. The first energy level can hold up to 2 electrons, the second energy level can hold up to 8 electrons, and the third can hold up to 18, but since we're sticking with the first 18 elements, we'll never need it to hold more than 8. So we use a P for protons and N for neutrons, and we use a dot for the electrons. We have to make sure that we fill up each energy level before moving out to the next one. So now let's move on to looking at some examples. So here you'll see that I have created a list of elements and told you what their masses and the number of protons are. Again, I can get this information off the periodic table, or it might be the mass might be provided to me. Like I might be told that I have helium-4 or carbon-12 or oxygen-16 or whatever that mass is. Remember, that mass number is specific to that isotope, and it can be different from one isotope to the next. Now, today we're just going to be working on atoms, not ions, so our electrons will always be equal to our protons. So the first thing I'm going to do is figure out how many electrons and neutrons the element has, and then I'll go on to start actually drawing the Bohr model. So for hydrogen, because I have 1 proton, I will have 1 electron. And to figure out the number of neutrons, I do mass minus protons, so 1 minus 1 gives me 0. So I'm going to draw a circle for my nucleus. I'm going to put a P1 and an N0 because I have 1 proton and no neutrons. Then I'm going to draw my first energy level, and I'm going to add my 1 electron to that first energy level, and that's it. I'm done with hydrogen. I don't have to do anything else for it. If we move on to helium, since I have 2 protons, I have to have 2 electrons. And to find my neutrons, I do 4 minus my 2 protons. It gives me 2 neutrons. So I draw my circle, P2, N2, and I draw my energy level, and I add my 2 electrons to it. Then we can move over to lithium. Since I have 3 protons, I have to have 3 electrons. And 7 minus 3 gives me 4 neutrons. I draw my nucleus, P3 and 4. I go out to my first energy level and I add 2 electrons here, but that's it. I can't add any more to that one. The first energy level can only hold 2, but I need to add 3 electrons. So that means that I need to go out and create a second energy level. And then I can put that last electron on that second energy level. Moving on to beryllium, I need to have 4 electrons, and 9 minus 4 is 5 neutrons. P4 and 5. I'm sorry, that's getting a little bit small, but I want to make sure I have enough room to draw my energy levels. So my first energy level has 2 electrons in it, and then I need to add my second energy level so that I can add 2 more electrons to it. We look at boron. We have 5 electrons and 6 neutrons because 11 minus 5 is 6. So we have our nucleus with P5 and 6. First energy level gets 2 electrons. Second energy level gets 1, 2, 3 electrons. We're going to keep moving up and doing this with each one. And I'm going to go ahead and move on to the next slide. You can take a look at these on your own and try them on your own. But I'm going to go ahead and move to the next one so that we can see what happens once we get to neon. So neon is going to need to have 10 electrons and 10 neutrons. So I'm going to have P10 and 10. I can put 2 electrons in the first energy level, and in the second energy level, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 electrons. I draw them in pairs just because it makes it easier to count, but you can put them each individually, that's fine. Now neon is at 8 on the second energy level, which means that when I move on to sodium, I'm going to have to add another energy level because I'm going to be out of space. Because remember, that second energy level can only hold 8 electrons. So if I look at sodium, I need to have 11 electrons, and 23 minus 11 is going to give me 12 neutrons. So now I'm going to have P11 and 12. My first energy level is going to have 2 electrons. My second energy level is going to have 1, 2, 3, 4, 5, 6, 7, 8. But I still need one more, so I'm going to add a third energy level and put that last dot on there. If I look at magnesium, I have 12 electrons and 12 neutrons because 24 minus 12 is 12. So I end up with P12 and 12. First energy level holds 2. Second energy level will hold 8. But I need 2 more, so I add my third energy level and I put 2 on that third energy level. Again, I'm going to keep on going until I get to argon, which has 8 on the third energy level, and that's the last one that we're going to use in our Introductory Physical Science class. Again, with Bohr models, your key things to remember are that your protons and neutrons go inside the nucleus. Each energy level has dots on it to represent the electrons. You have to fill one energy level before you can move out to the next one. The first energy level can only hold 2. The second energy level can only hold 8. I hope that you found that helpful, and good luck with your Bohr models.